Okay, we're doing some GPZ noise tests. So I've got a detector that the fellow says is noisy, and what we're going to do is fire it up in the workshop. So we've got some ambient noise, and I'm going to compare the noise levels with another detector and just see if it is noisy. Um, when I got this detector, the gain was on 17, which could explain why the fellow thought it was noisy. You don't use these detectors at such high gains. I see people do. They crank it all the way up, and it's just a bucket of noise. You run these detectors probably around about 8, not up the other end, and that's where they perform the best. You don't crank the gain right up on them. You'll miss a lot of targets at just being in the noise. But we're going to fire this one up. I'm just going to do a reference. We've got a X coil there. Got a dongle into the detector. I'm using his interface or display, and I'll just swap detector to detector, and we'll just see how the noise is. Got a microphone there, speaker there. We'll see how it goes. I'll just do some arbitrary depth test. Just make sure that everything's going. There, the waveforms up. Transmit waveforms popped up on the oscilloscope for the ZZ. And we'll just do a frequency scan. Oops, go down there. And I'll just let it do an auto scan. And we'll get the quietest part of the spectrum within reason. Let's see what happens. It's having a good think about it. This is our reference detector here. This is the one that's meant to be noisy. So we'll get an idea. What I can do, and I have done before, rather than sticking probes in the detector and all the rest of it, it doesn't make much difference. But what you do is you have your speaker and microphone exactly the same on both detectors, and the settings exactly the same on both detectors. And what you can do is get your audio clip off both, and you can put it through a matched amplifier, and you can just put it on your oscilloscope and look at the audio peaks where they overlap. And if there's noise, you'll see greater impulse noise on one than the other. So if they're all set up the same, it should be within a couple of percent. Unless it's, a Monday morning detector or a Friday afternoon detector, it might be 10% difference. But here we go. We're going to try this out. So I'm not going to yabber because I'll just put the audio peaks up. So I'll let it go for a bit. And I'll test it out with the 0.05. Clean signal at 7 centimeters. Not that it's really 7 centimeters. I've got things jammed in there. The ruler's there. The coil's on a bit of an angle, but as long as nothing moves, we'll get identical readings. So I'll turn this one off. That's a one of our connectors we use, and they are extremely tight, which is a good thing, so you don't get crackles in your audio. There we go. Put that down there. I'm going to undo that too. Okay. That's one. And I'll get the other. Now I've got to do everything absolutely identical. All good. Putting this on is really difficult. Get in here. Out you come. Where this sits, no one knows. You have to go one way or the other to get it on. The display one's always difficult. Okay, I've got that there. Put that there without moving anything. Stick that there. Speaker's in the same spot. We put the dongle in. Okay, in we go. We'll tighten it up. Not that it needs to. Okay, we'll fire this one up. We'll see how we go. You always notice when these first turn on, have a look at the transmit waveform there. It's really spread out, and then when it fires up, it doubles the frequency. There we go, doubled the frequency. Very interesting, isn't it? So it must do a bit of a sniff. Okay, this one here. Imagination. I think it's just interference. But anyway, what we'll do, we'll give this one a... okay. Away you go. We'll do a frequency scan on it. Maybe it is a little bit noisy. We'll find out at the end of the scan. Unless something's been turned on in the house, like a washing machine or dishwasher or something. Okay, it's done its scan. Let's have a look. That wandering and up pitching, that doesn't sound right, does it? Let's give it a... It sounds a little bit off. Oh, no. Someone's fired up the vacuum cleaner. I can hear it. So we've got an AC motor out there running down the hallway. and it's going to pick it up. As it gets closer, it's getting closer. Let's have a listen to the detector as it gets closer. Yep. I don't know if you can hear the vacuum cleaner, but I can hear it sucking away out there. And yeah, it's probably going to cause issues. That's why I usually do a lot of these tests around midnight or early hours of the morning when there's no humans running around doing things. There you go. Getting closer now. So yeah, we can have this detector set up as a vacuum cleaner detector or electric motor detector. But you know, it's just the way it is. Can't get rid of that. Oh, thought it stopped. No, it's gone. It's gone back that way. So, and those funny pitching up wide sounds, they're not as bad as what they were. Still there. Well, there you go. That's why you can't do a lot of tests and measurements during the afternoon, because this is what happens. It all goes out the window. So a lot of this stuff, even when I used to do a lot of radio stuff years ago, I used to do it. I'd probably start at 1 a.m. and work till about 5 a.m. because everything was quiet. We were doing very low noise measurements, but we were doing it live. We had remote low power transmitters set up, and you just couldn't have anything on anywhere around the place because all your measurements go out the window like this. Yep, useless, useless. Anyone doing anything in your house, uh, even fluorescent lighting will cause wideband noise. TVs, computers, vacuum cleaners, dishwashers, clothes washers, drying machines, anything, especially that has a motor in it, electric motor of any shape, size, or description, will completely screw up what you're trying to do. And the other thing I just noticed too with this detector, um, the noisy detector, the battery's just about flat as well, so that's not going to help. So um, it could be screwing with the power supply a little bit, or its own BMS system, battery management system in the battery, um, have been known to do weird things when the battery voltage gets very low, close to cutoff. Things turn like this, on and off, or try and compensate or whatever they're trying to do. And sometimes with a low battery, they will make noise in the detector. So I didn't notice that before, but this battery is going to need a charge. So I think that one there is okay. Let's have a look. Yep. I put references on my battery so I know if it's charged or not charged. So yeah, well, that actually is my detector. It's a reference detector. So that will need charging. I think I'll pack this up and I'll go and do some, you know, build some boards and stuff like that while we have the noise out there, because I can't do anything about it. As soon as I said that, it stopped. I'm not joking. It stopped. Okay. I better put, so we don't get all these batteries muddled up, I'm going to get the slightly in there. Okay, I can see that. Blue. It's a gel pen, so I can see that I've put the customer's name on that battery. I was going to fire this up with the battery out of mine. So, excuse the buffhead. But here we go. So everything's moved now, hasn't it? But I'll have a listen to the detector just to see if we have any improvement whatsoever. Yeah, go on, move. Everything's going to move now. So, gee. Okay. Well, our reference isn't a reference anymore, but we'll just have a listen. Oh dear. How sensitive are these microphones? Can it hear them out there? Probably. Okay, fire up. Chop, chop. It should make noise. There we go. Now just have a listen if it makes that whoa noise. I'm not joking. The vacuum cleaner's fired up again. Not my day. I couldn't plan it to be as perfect as stop, set up, turn the detector on, and bang, there it goes. Actually, I'll tell you something which might intrigue you all. These detectors, even the vacuum cleaner's going, this detector's more stable with my battery on it. It's not getting those big, long, drawn out sounds that were coming through before. When the vacuum cleaner gets close, it probably will, but it's not as bad as what it was. I'm not joking, right? Putting on the fresh battery, I've gained 1 centimetre in detectable height on that. Before I said 7, just because I got a jam like so. That was 7. And that was a threshold on the other detector. Now, this is a lot more. There's 8. There's 9. I can hear it at 9 in the noise threshold. So just by putting on a fresh battery, the detector has increased depth. Now what we'll do, I'll put the other battery on, we'll try it. This is interesting, isn't it? You would never think of it. You would say, battery's a battery, it's got its own switch mode power supply in there, does all its own voltage regulation and everything. Maybe not so. Let's prove it out. So that's the good Woody battery. It's written there if you can see it. So, and there's this one. This one's in the red. The other one's full charge. So we'll give it a go. Damn you, vacuum cleaner. Okay, here we go again. We'll try it for flat battery. No, it's not flat. It's actually still good. The detector would, if it was flat, it wouldn't turn on. But it's down. It's down a fair way. Now, there it goes. She's doubled the frequency and see what happens. Here we go. I'm not joking. It's weak as water and I can't get over 7. Now, you guys are running around at the end of the day getting your battery down and strange things happen. I'm not joking. Have a look. It's at 7. It's not a signal there. I'm not joking. It's friggin' it's probably as it's getting down and down in voltage. The detector's starting to really, yeah, it's not putting out as much as what it should maybe. But no, we can always have a look at the amplitude here. That's just a pickup coil. And actually, I will mark that because I've got markers there. I can mark it. Okay, not that way. Oh, come on. I can't see the damn thing. This is what's going on. There we go. Make it brighter. Maybe if I push that, that would help. Helps when you push the right button. I was just changing it from frequency to microseconds and whatever. Anyway, let's have a look here at those peaks. Okay. There. And there. And that's with the... see, we don't know which part of the circuit's getting affected. Why would it be affected so much if the battery volts gets down a little bit? It should be internally regulated, but we'll see. 0.05. Have a look at this. This is ridiculous. I'm down at 6.5, and I'm getting a very wishy-washy signal. So all this stuff's educational, isn't it? Because I didn't even know that. I would never have thought that would happen. Because I know these things have internal power supplies. So obviously, as the battery goes down, performance goes down. So it seems. Okay, I've got those locked in there. We'll just do a battery change. Always check the battery connections too. If they get a bit oxidized, you can get voltage drop through the oxidized contacts, which you don't want. So here we go. Fully charged battery. And when you put these batteries in, make sure that you push it in hard before you use these little things on the side, these little, I don't know what you want to call them, clips, wings, whatever. Because if the battery's not in and you push it really hard and it doesn't go in all the way, what happens? It will snap right on where those metal pins go, and you'll get cracks through those holders there. So always hold them in like so, and just take the pressure off it. Even though there's a fair bit of pressure there anyway, you can just go, just so it doesn't leave it with a lot of pressure. It will break if it catches and doesn't go all the way in. And that was just dead easy. If you do it straight up, sometimes you got to push really hard as it goes past a particular angle, and it puts a lot of pressure on those pivot points. So you don't want to do that. Anyway, we'll turn this on. It's interesting, isn't it? Very interesting. Battery level and noise and depth. So no settings have changed. I'm using the same head unit, so it's all the same. Okay. I'm not joking. Even though the noise is still there, it's not as chattery. It hasn't got the through it. I'll have to look back at the audio, but I'm pretty sure it sounds a lot better. So let's get this fully charged battery, 0.05. We'll see how we can pick up. Up at 8. I'll do it at 6, because remember the other one was doing it wishy-washy at 6. I'll just do it at 6. It actually proves it. A battery that's down, you're going to lose performance. Don't ask me why. I mean, if the battery was feeding the transmitter directly, I'd understand. But it doesn't. There is a switch mode power supply there. What I need to do is pull the detector apart, measure the voltage actually on the transmitter, and try different voltages going in where the battery connections are, and just see if it actually affects the transmitter output. There's something weird going on there, guys. You want to be careful, by looks of it, having a battery that is down. It's going to cause some issues. And maybe that extra noise is its own switch mode power supply having a bit of a hissy fit, because it's going to switch more current, trying to get the voltage up. The more voltage in, the easier it is for it to step up to whatever it's stepping up to, whatever it does. It might be 10 volts or something from 8, who knows? Might be 15. I don't know. I've never bothered measuring it. It's just a power supply. But I think I will, because there's funny business going on. I'm getting clear signals up at near 9. It's in the noise, but I can hear them as I go over. I can, time it with my ears. But yeah, it was dropping right off with the battery that was nearly flat. So, oh dear me, guys, do some experiments yourselves on this, because it's very, very interesting. And the vacuum cleaner stopped, by the way. So just trying to see where I get on threshold. Yeah, there's too much noise coming in. I thought I was getting up near 10 then, but I don't think so. It's just riding in the noise. So yeah, I should do a few more configuration changes on this coil here and quieten it down. But very interesting indeed, that battery power is having that sort of effect. It might only be 7.8 down to 7.4 volts or something, a very minimal voltage difference, but there's changes in the detector. Oh, hang on, I forgot to look at the power level, didn't I? I said I was going to look at the power level. Oh no. I'll put it back on. Oh dear. Distraction. Okay. I can see right now. Come on, do your double. I want to see it do double up power. Double the frequency, and away you go. It looks to be very close to where it's meant to be, but what we're going to do is going to quickly change the battery over again. Just look. Okay. Let's check the battery so I don't muddle them up. Never know. Okay. Push it in. Clip. Push that one. Yeah. See it? It's hard to push. Something there is not in the right spot. Okay. I don't like that at all. That is really, really off-putting. So I'll loosen that one off. Just check all this. Put that one there. Really easy. You put the other one on. Really easy. That doesn't make any sense. But I was pushing really hard on this side then with the other one done up. I don't know. Maybe it's not symmetrical or something. I don't know. Maybe there's a little bit of movement after it got injection molded and something's not right. But anyway, turn this thing back on. Oh dear. Let's see. Let's see if there's any different, because I can tell if the transmitted power's down. You'll be able to see it on the oscilloscope. It's actually no joke. I'd say, ooh, it's about in a reference line, as in the display line thickness different. So it's down a little bit with that nearly flat battery. It's down a tiny bit. Okay. That's 6, 7. I can't get past 7. 7's pushing it. The other one was definitely getting up. But if you look very I don't know if you can even see that, can you? Here we go, earthquake. Don't know if you can see on the, I can't zoom, damn it. But yeah, the indicator lines there, those bright points are about a line width lower with this battery. It is having an effect. Like, it's completely measurable. So there you go. And sometimes these microphones make noise, but I don't know if these are new ones. I'm just going to move this one away. Hasn't made any difference. So these are probably okay. I'll put it near the coil. Oh yeah. Maybe it's just such a massive metal it's picking it up. No, I don't know. There's something going on there, but yeah, a lot of it's got magnets on it. I want to pick up resistors, but there is a lot of stuff going on here. Yeah, I should actually have the audio hooked up on the oscilloscope, slow it down, and have a look at the peak waveform. That's probably the better way of doing it, but we've got a speaker, so we'll use our ears. Okay. So at the end of the day, is the detector noisy because the power supply's, well, battery's lower? Is that having an effect? Does it affect the internal switch mode power supply and generate noise or whatever's going on? This is just a quick muck around test. I'm going to have to do it a bit more scientific than what I'm doing, but I'm just showing how you can do it yourself to test things, test your own detector. Um, definitely just experiment. Make sure everything's the same and experiment. You can experiment between two detectors like this and see if one is doing something different. But you really want to, in both cases, uh, use the same coil and use the same battery on each, because if the battery's down and you're going to have a discrepancy, and you'll blame the detector, and you should be probably blaming that the battery's not charged or the battery's on its last legs or something. But just one thing to watch out for, and like I say, I'm going to work out why. I'm going to check out the way these detectors do their voltage regulation to the transmitter. And I'll probably also look at the plus or minus 5 volt rails just to see if anything does drop in that area. I know it's got 3.3 volt rails for the micro, and I think that's pretty. It's a long way down in voltage. It's not going to have an issue going from 8 or 7 volts down to 3.3. But the other voltages, where there's current, especially on the transmitter, we'll have a look at that. There is a little discrepancy there, but I don't know if it actually makes a lot of difference. Um, it's probably 1 or 2% difference, if anything, with the lower battery on the transmit. It's not going to make 10% difference on your detectable measurements. So unless the power supply, when it gets low, starts generating a lot of noise, a lot of switch modes, when you push them out of specification, they get noisy. They start generating all sorts of diva when they switch, and it causes sidebands and noise radiates out. So you can check for that as well. We'll do some in-depth testing. That means I've got to pull it all apart and interconnect everything and have it all on the bench and be able to get at everything. So it's a big job to do, doing that. So yeah, that's just interesting. Anyway, you can experiment with your own 7000s. Just test them with a dead battery, deadish, not totally dead. Say it's I don't know, it's 3/4 used or something. Try it at that level and try it at fully charged. Just see if there is a difference there. And if you do it, give me some feedback. Leave the feedback in the comments, because if you do all this stuff, no one knows. It's good if we collate all the data and see if there's a consensus. Either it makes no difference, or it does make a difference, or it depends on the actual detector, which who knows. stranger things have happened. I've had all sorts of stuff happen in the old GPs. Um, Lots of stuff like intermittent faults because one side of the ICs weren't soldered down the board. The solder mask was stuffed when they put the chips on. That was quite funny. And then they put white paint over it, so you never know. Uh, yeah, I did know. Just touching the board, it was turning on and off. So I scraped the white paint away, and all the chip legs are just sitting on the pads. There's no solder, none, zero. Lift it up. Um, but yeah, that's production. It's not design fault. It's whoever was doing the loading of the boards for some reason. Someone must have done something, blocked off the solder or the stencil when they put the solder paste through. Might have put a bit of sticky tape on there or something, and it just wasn't putting any solder down the board on one side where one of the chips were in the middle of the board. And they all just sitting there like, it's all this side soldered on and sitting there flop, flop, flop. Not that bad, but, it wasn't connecting properly. So as things moved around and, a little bit of thermal heating when you're using the detector, things would move and probably the legs would go like this and turn off and turn on. But anyway, that's a long time ago. So I haven't seen anything like that since. Or have I? No, I haven't seen anything like that since. It's all pretty good. Oh, I have. Come on, I have. Um, I don't know if it was the detect. Well, actually, uh, I had a fellow dropped in a 6000. He dropped it, but he said he didn't drop it really hard, and it was noisy. And I just looked at the detector. I just opened it up, see if anything come adrift. And one of the plastic board interconnects had a crack in it. So I thought maybe it didn't have enough tension there, holding maybe a ground pin or something there. So eventually I got one. Well, I actually got some because they're very hard to get, and put it in and replaced it. And to me, it sounded fine. It worked. It was all the rest. And then he tells me it worked fine for a few minutes, and then it went noisy again. I'm thinking, oh God. And what it ended up being, I don't know how hard he dropped it, but it ended up being he stuffed the coil. He dropped it, and the coil's gone noisy. So he put another coil on it, and the noise went away. So there's some trickery for you. You're thinking something's on the board that's not quite right, and you replace it, and you test it, because I test it with my own coil, and I went, oh yeah, that's fine. So yeah, get caught out with that, and anyway, we'll have that 6000 coil to pull apart. Going to drop it in, and we'll pull it apart and see what's going on. So you'll learn a little bit about 6000 coils, not the MindLab ones, another brand, but we'll just have a look-see. We'll have a bit of a poke and a probe and a measure. It's interesting that a coil had gone noisy. The only way that could happen is somehow a fracture through the connection or the shielding itself, where a shock has cracked it or something. I don't know. If it's just the carbon, let's just dab more carbon over the crack and fixes it. But who knows? It might be that little ferrite box in there with everything else in there. Something's come adrift, so I'll have to look at that and fix it. So I'll make a video on that when I get it. See if we can probably fix it. Pretty sure. But yeah, anyway, 7000s, guys. Interesting. I'm going to delve more into it. I might do my next look-see in the early hours of the morning, just so I get rid of the noise around the place, and makes it a lot easier. But the vacuum cleaner stopped, and dare I get back onto this now, it'll start up again. Something will happen, or the washing machine will go on. Beware of the washing machine. As it goes one direction then the other, it's got a H-bridge driver in there, it turns it round. The thing is with those, they make so much interference. Even if the next house is doing it, I'd know about it with these detectors. You can tell the way it pulses. So yeah, you got to get away from everything when you do testing, and forces you to do it when everyone's asleep. Anyway, enough yabber. I've got more work to do, so I better get into it. Catches.